when you're given a speed time graph like this one, remember, acceleration time graph, speed time graph, distance time graph. Let's say this here. When you're given this speed time graph, the gradient here represents the acceleration. The area underneath the speed time graph represents the distance traveled. So when you're given when you're given a speed time graph here, sometimes you might want to know the distance traveled between, let's say, 2 seconds and 4 seconds. So sometimes you want to know the distance traveled between two different times. So in order to find that out, you have to work out the area underneath the speed time graph. Okay, so if you want to know the distance traveled between 2 seconds and 4 seconds, then you have to work out the area underneath this graph. So here it's really a trapezium. Okay, hang on, let me clear this up. So it's like this. It's like you working out the area of this thing here. This area here represents the distance traveled between 2 seconds and 4 seconds. So sometimes when you're given a speed time graph, you might want to know the distance traveled between 2 different times. So you need to work out the area of a trapezium. So we need to think of a more efficient way of working out the area of a trapezium. In one of the earlier videos, we did this. Hang on, bear with me. Hang on. In one of the earlier videos, we did something like this. We cut the trapezium up. Hang on, let me just move this down. In one of the earlier videos, we cut this up like this, and then we worked out the area of this rectangle, and then we added to this. Yes, you could do that, but it took us quite a long time. Let's develop a better method of doing it. So let's call this A here, and this length here is A. Okay, this length here is B, and let's call this length here C. Okay, so let's try and develop a more efficient way of working out the area of a trapezium. So let's split this up. Okay, so in effect we are going to do what we did before, but then we're going to simplify it, and then it will become neater towards the end. Okay, so first let's work out the area of this rectangle here. The area of this rectangle is given by AC, because you would get A and then you times C. Okay, now we need to add it to the triangle. So, well, the triangle here is, well, you need this length here. Well, this length here is, well, you know the whole length here is B. Now, if you cut this bit, if you cut off A here, because this length here, look at this length here is A. Okay, so if you cut off this A bit, then that will give you the length here. Okay, so this length here is actually B take away A, and that exists in a bubble because you've got to work that out first, and then you times the across here, which is C. So this triangle here is really this thing times by C, and that will then give us the whole rectangle, and then we got to cut it in half, so it would be this. Okay, so hang on, the rectangle is given by this rectangle down here. Now up here it will be B minus A. Okay, and then we've got to times it by C. So basically B minus A is here times by C, and then we've got to divide it by 2 because it's a triangle here. Okay, so this whole trapezium is given by this. Okay, so now let's tidy it up. I'm going to turn this into a fraction. Okay, so it's going to be AC over 1, and then plus, well, I'm going to multiply this out. So this will be BC minus AC over 2. Okay, and then I'm going to times top and bottom here by 2. I want to merge the two fractions together, but I need the two denominators to be the same. So that's why I'm timesing top and bottom by 2 here. So this will be 2AC over 2, and then plus BC minus AC over 2. So this here represents our whole trapezium. But let's continue tidying up. So now that the two denominators are the same, we can merge. Okay, so it would be 2AC plus BC minus AC. Okay, so this here is like your Liga here. This is your Liga. This is your, I don't know, your Eligraph or whatever. These two are the same. You've got a Liga here and a Liga here. So it's just like you saying you've got two Ligas. Take away one Liga, so that will leave you with one Liga. Two Ligas, take away two Ligas, take away one Liga here. That will leave you one Liga. So this would be AC, okay. And then, well, this is your Eligraph. There's nothing that's the same as this. So you can just leave it as BC. So this will be, so basically this whole thing here will become this. It's getting simpler now. Now look what's in common here. C is common. C is in common. So let's factorize. Okay, so let's factorize this. So this will be C bracket A plus B close bracket over 2. Okay, and then here I can take at the moment I've got this times this thing here, so I can actually take the C out. So it's like this: C multiplying with A plus B over 2. Because when you times a fraction, you multiply it to the top. So I'm just working in reverse. I'm taking the C out. So it's like this. So the area of the trapezium can be visualized as this: C times A plus B over 2. Okay, so the area of the trapezium can be written as this. What that means is, well, look at this here. Remember this formula here represents the whole trapezium. So it's hang on, let me tidy this up. So this is A, B, and C. We said that it's C times A plus B over 2. Okay, so the area is given by this. So if you look at this here, hang on, let me just tidy this up. So it's hang on, let me just tidy up. C, and then you've got A plus B over 2. Okay, so look at this here. Just concentrate on this bit here. So whenever you want to work out the let's say you want to work out the time travel, the distance traveled between 2 and 4. All you have to do, looking at this here, all you have to do is just get A plus B and then divide it by 2. So what that means is just get this height here plus this height here divided by 2. When you get this plus this and then divided by 2, it really gives you the average height of the two. Okay, the average height of the two. And then, well, this height, this short height plus this long height here, when you add the two together and then divide it by 2, that will give you the average of the two. So this is in the middle of the two. And then all you have to do is times by C. And then that will give you this area of, well, this rectangle here represent, well, it would be the same as a trapezium. So if you look at the trapezium here, look at this here. If you get this height here, and then add this height here, then divided by 2, that will give you the average here. And then all you have to do is work out, well, times the C here. So what I'm trying to say is that this triangle here is the same as this triangle here. Okay, it just moves. You just rotate it. So working out this rectangle is the same as working out the trapezium. So when you are given a trapezium like this, get this height plus this height, and then divided by 2. That would represent the average height of the two. And then all you have to do is times by C. So basically, it's this triangle. These two are the same. Okay. So the main point of this video is that I'm not even going to write down the formula for you. Just remember that when you're given a trapezium like this, Just get A plus B divided by 2. That will give you the average of the two, and then times by C. Okay, so this plus this divided by 2, that will give you this height here. Okay, the average of the two, and then you times by C. You drag it along C. That will give you the whole area. So the area of a trapezium is this height plus this height divided by 2, and then times C. Okay, that will just remember that. Just commit it to heart. So if you want to know the distance traveled between 2 and 4, just get this height here plus this height here divided by 2, and then times the across here. Okay.